All right, just as a quick reminder of what we had done previously when solving systems of equations, if both equations are solved for y, then we just set them equal to each other. So in this first situation, if I was solving this system, I would start by saying 2x plus 3 equals 1/2 x minus 2. I would solve for x. I'm not going to do that now since we did these problems previously. And then I would substitute to find y. All right, so that was what we did in that situation when they were both y equals something. If one equation is solved for either variable, so it might be solved for x or it might be solved for y, then we substitute the expression into the other equation. For example, in this situation, it's solved for x, so I'm going to put this into the other equation for x. So I get 2 times y minus 3 minus 3y equals 5. And then I would solve for y. And then I would substitute to find x. So that's what I do in those situations. We're going to look at a little different situation today. And first I want to start with this that might seem obvious to you, but we are going to use this. Think about this. If a equals 2 and b equals 3, then I think you would all agree that a plus b would have to be equal to 2 plus 3. And so that should make sense. A plus b would have to equal 5 if a was 2 and b was 3. So we're going to use that idea to solve systems of linear equations, and that's actually what we're going to do today. So our title of today's lesson is Solving Systems of Linear Equations by Elimination, and that's the method we're going to use. It's a little bit different than the substitution method. So here's the first example, and you're really going to like this one. I'm going to use that idea that if a equals 2 and b equals 3, that a plus b equals 2 plus 3. So what I'm really doing is I'm adding the left side together and I'm adding the right side together, and I get a true statement. So I'm going to do that here. I'm going to add the two equations. And when I do that, negative 7x minus x, or plus a negative x, is negative 8x. Positive 4y minus 4y. Well, those cancel. 9 plus 15 is 24. Wow. The y is gone. It's been eliminated, thus the name elimination method. So now I have negative 8x equals 24. So when I divide by negative 8, I get x equals negative 3. Well, that was rather painless. So my first solution is really easy. Now remember, I have to also know y, so I need to substitute into either equation. So I'm going to do that, and I'm going to use the first one. So I have negative 7 times negative 3 plus 4y equals 9. So I'm solving for y. So I get 21 plus 4y equals 9. Subtract 21, and we get 4y equals negative 12. So we get y equals negative 3. So my solution, negative 3, negative 3. Now what does my solution mean? That means if I graph these two lines, they will cross at the point negative 3, negative 3. Don't forget what that means. That means that this system of equations is consistent and independent. We have one unique solution. All right, next example, solve the system. Negative 8x minus 9y equals 18. Negative 2x plus 9y equals negative 18. I'm going to do the same method. Now notice I have a negative 9y and a positive 9y. So I can see that when I add these two equations together, these are going to be eliminated. So I get negative 10x equals 0. That's okay. When I divide by negative 10, you're allowed to have 0 in the numerator, and that just means x equals 0. So that first part's done. Now I substitute. I'm going to substitute into the second equation. Negative 2 times 0 plus 9y equals negative 18. Well, 2 times 0, that's just 0. So I get y equals negative 2. And my solution, 0, negative 2. Again, this system of equations would be consistent and independent if we graph that system. Well, here's the third example. Solve the system negative x minus 6y equals 7 and negative x plus 5y equals negative 15. Now notice this time, if I add the equations together, the y's won't drop out, but neither will the x's, because a negative x plus a negative x is negative 2x, so they won't drop out. But if this were a positive x, then they would drop out. So what I can do, actually I can subtract the equations, but what I prefer to do is to think of multiplying this equation by a negative 1. And when I do that, I get a positive x, a minus 5y, and a positive 15. My top equation is not going to change. I'm going to leave that alone. Now I can add the equations together, and when I do, the x's drop out. I get negative 11y equals 22, so y equals negative 2. To solve for x, I just substitute, and I can do either equation. I'm going to do negative x minus 6 times negative 2 equals 7. So negative 6 times negative 2 is positive 12. So I get the opposite of x equals negative 5. So that means x equals 5. You can multiply both sides by a negative 1 to get x equals 5. So the solution to this system of equations is 5, negative 2. So on this one, it was different because adding them, they didn't just drop out. But if I multiplied one of the equations by a negative 1, then I can add them together. This one you can see is a similar situation. Adding them isn't going to help because I'm not going to eliminate a variable. Remember, my goal is to eliminate a variable. However, if I multiply the bottom equation by negative 1, and I'm going to do a little shortcut, I'm just going to say that makes this a negative 3x, this a negative y, and this a positive 14. So really what I did is I multiplied by a negative 1. Now I can add these two equations together. I get negative 9x, the y's drop out, equals 18. So x equals negative 2. Now I need to find y, so I'm going to put it into the top equation, but it wouldn't matter which one. Negative 6 times negative 2 plus y equals 4. So we have 12 plus y equals 4. Subtract 12 from both sides, and you get y equals negative 8. So my solution is negative 2, negative 8. Again, that means this system would be consistent and independent because I get one unique solution, which means if I graph these two lines, they will cross at the point negative 2, negative 8. Well, I'm going to need a part 2 to this, so because I have a few more examples, so go ahead and switch to part 2.